Hello and welcome to Lab in Computer Architecture. I am Nachum Danzig. I'm a lecturer at the Jerusalem Academic Center, and we're looking at lab number 6, which is multiplying matrices. Now, you have a different course where you probably learned how to do that, but I'll show you an example. Here's the question from our Moodle site. Lab 6, Computer Architecture, multiplying matrices. We want to multiply two matrices, A times B. The dimensions of A are Mn and of matrix B are Nk. That means that the n is the same number here is the same number here. It could be like 7 times by 3 and 3 by 12. But the 3 and the n's have to be the same. If the person puts in numbers, the person is going to be asked to put in the dimensions of the two matrices. And if they are not matrices, and if they're not correct, then he'll be asked again until he puts in valid numbers. In other words, the n's have to be matching. And then the program should let, right, that's what I wrote here. The program should let the user enter the dimensions. If the n is not the same, then the program should request the user enter valid. Once the dimensions have been successfully accepted, the program needs to ask the user for the correct number of numbers. He's got to put in the numbers and store each of the sets in arrays. For matrix A, enter m rows of numbers where each row has n numbers. And so for matrix B, we want you to display matrix A as a matrix. In other words, not all in one row, but in rows and columns. And matrix B in the same way. And the multiplication of the two matrices as C also to display in form of a matrix, which means columns and rows. Now here's an example just to show you. You can look this up on the web anywhere you want. You'll find examples of matrices. There's even calculators that will calculate for you matrix multiplication. But here's an example. 1, 2, 3, 4, 5, 6. Notice that this is 3 by 2. So this is 2 by 3. So the n's are the same. This is 2 by 3, and this is 3 by 2, and this is 2 by 3. So the first multiplication will be 1, 2, 3, which is the first row, times the first column, 7, 8, 9. And that means I'll do 1 times 7, 2 times 9, and 3 times 11. And I'll add up the whole sum, and I'll get 58. And the same too for the second row. This first row again times the second column. And then we go to the second row times the first column, and the second row times the second column. If there'd be another column here, would be the same second row, times the third column. And the result wouldn't be a 2 by 2 matrix. It would be larger. I could also have this number. Well, actually, there has to be 2 columns, but there could be more rows here. Here, there could be more than 2 columns. Anyway, you can try other examples and see how it's supposed to work. Let me show you example that I started. My solution is not finished, but it's a good way towards the solution. So the first thing I decided to do was make 3 arrays. Each one, I made them size 32. You can make yours larger because you don't know what the numbers are going to be, but I know what the numbers are going to be. Instead of doing input-output, because it's a little bit tedious here, I skipped that part. I figure you guys know how to do that, and I just put in the dimensions into my S's. You should obviously do input-output to get this from the user, check that they're valid. I'm skipping all that. I've got now the inputs in S0, 1, 2, and 3. This is 3 by 2 and 2 by 3. And I have my 3 matrices. So what I decided to do is store the result in a third matrix. You don't actually have to do that because all you have to do is print it out, so you could just print it out as you calculate it. But the first 2 you will have to store. But you could do it the way I'm doing it. I find it easier to think that way. You just get the whole matrix all set up and then print it. And I'll use the same printing function for each of the arrays, which you can write a function for that, which you know how to do. Okay, so now the first thing I'm going to do is loop for set A, for matrix A. And I do the address of A, the matrix A, which is up here, right? A, is stored in T0. And then I got to figure out how big it's supposed to be. Now I'm going to make some kind of arbitrary size like 300, but in reality, it's going to it's going to stop at a certain point. So how many elements are there? Well, it's 3 times 2, 6. But I'm not going to write 6. I'm going to write multiply S0 times S1, put it in K. And then K is 6, but I need to have it in words. So K will be multiplied by 4. I do that the most efficient way is by moving it to the left by 2 spaces. So that's what I do by shift left. And now I take that K, which is, let's say, 24, and I add it to my pointer to the beginning of the array, which was T0. And T1 becomes a pointer to the end of the array. And now I'm going to loop until the pointers equal each other. This is where I don't have to have a counter and a pointer increment. I'll just have the pointer increment, and the pointer will act as my counter. Now, I'm going to check if I'm done. I'll start. First thing I do is check if I'm done. In other words, maybe the dimension he gave me is 0. So, or maybe I'm at the end of my loop. So I check if my first pointer is equal to my end pointer, T1. If it is, then I'm done. End loop. If not, then input the number, store the number in the beginning, increment the counter by 4, and continue. So I'm going to increment each time my pointer until my pointer gets to the end. I've input the values. I'm going to do the same thing for matrix B. So that means I got to have a pointer at T0, can reuse T0, and then I can multiply S2 times S3 this time, the second pair of numbers. And I get the result in K0, and I shift it left, and I make my pointer, and again, I start with my loop, and I call it end loop 2, and essentially I do the same thing I did before. I input, and I increment until I'm done. And I'm at here, and I got the two numbers. Notice that what I did was I stored the numbers in a one-dimensional array, both of the matrices, because it's going to be too complicated to try to make two-dimensional arrays where I don't know originally the size of them, the dimensions, the height and the width. So I'm just going to make everything a one-dimensional array, and I'll just know how to jump to the right places. In other words, let's go back to the Targil. In the first one, it's no problem. I'm going to do 1, 2, 3 times 7. This problem is here, 7. The 1 times 7 is fine. It's both 0, 0. But this is 1. But here I've got to, I got to go, this will be place 0. It's place 1, 2, right, 3, 4. But here I'm going to go from place 0. I'm not going to go to place 1. I'm going to go to place 2. I'm going to go 0, 2, 4. So I'm incrementing by the number of columns that I have, which of course is a given. So we'll see how to do that in a minute. But the first part is easy enough. I just go incrementing by 1, or actually 4. So, wrong location. Here we go. So I have now stored the numbers, and now I'm going to do the multiply. Now multiply. Notice how I write my comments. I just comment the things that are a little bit unclear, like why am I multiplying these things? Size equals n times k. Pointer to the end of the array. I'm just explaining what I'm doing. I don't need to say like what this does. This is obviously, this. I don't need to explain that this is multiplying by 4. That's kind of obvious. But so in other words, your also end of, I make the name end of loop 2 is clear that that's jumping to the end of the loop. I'm done. I don't need to explain what I'm checking here because it's obvious that if I point to the end and I point to the beginning, I'm checking if they're equal. That's easy. Here I put comments. Well, I stored A, B, and C in T0, T1, and T8, but I wrote here counter for row, just for myself really, to remember that T2 is the counter for the row, and we'll see what T7 and T6 are later, but for now, T0 is the counter to the row. Now multiply first row of A times first column of B. I'm just reminding myself what the heck I'm doing. So it's good to make a comment like that for yourself in case you get called away in the middle, in case you space out and you don't remember what you're doing. It's important to make comments like that. Now, BEQ, what am I checking? If I reach the end of the row. Well, when do I reach the end of the row? If T2, what's T2? T2 is the counter for the row, equals S2. You say, well, how come I don't multiply by 4? Well, S2 is actually the number he gave me, which is like 3. How many elements are there in the row? S0 is 3. So I'm just counting, the T2 is just going to go up by 1 every time. Let's see where I did that. T2 goes up by 1 over here. So that's going to check if I've finished the end of the row. Now, assuming that I haven't, I'm not done. So I have to do my work. What is my work? First thing to do is take T2 and multiply it by 4. Well, the first time it's 0, so multiply by 4 doesn't do anything. But the second time it'll be 1, and you multiply by 4 because I need to go 1 space forward, which is actually 4 spaces forward, so that's what I do here. But that's just the index. That's just a number 4. I need to connect it to the pointer like I did before, so I'm going to take T3, which is my 4, or 0 in this case, and add it to the pointer to the beginning of A, which is T0. And now I've got T4. So T4 is like my temporary pointer, which is going to run through the array. T0 I'm leaving at the beginning. And now I say K is going to be the value at that location. Okay, so I got K, well, K0 is at the value location. What I'm going to do is I need to multiply two numbers together. The first one is going to be from the first matrix, which is going to be called K0. The second one is going to be down here, K1. It's going to be the other number from the other side, when I take the columns from the second matrix. And eventually I'm going to do K1 times K0, which are these two numbers. But first I got K0, I got one number. Yofi. Wonderful. Now I do multiply. What does this multiply? Well, if you think about it, I've got to do, let's look at the question, get the example again. I got to do 7, but then I got to do 9. What is 9? 9 is the pointer. Let's say the increment. I'm going counting by 1. 0, 1, 2. Let's say I'm at 2. That's the 3. I got to multiply by 11. How am I going to get here? Well, my counter went up to 2 now. If I do 2 times the number of columns, those two columns. 2 times 2. 2 times the number of 2 times the number of columns is 0, 1, 2, 3, 4. 2 times 2 is 4. I'm going to get to 11. Yeah. The next time, well, we'll see. It's going to be, we'll see how we do for the other rows. But that's basically what I want to do. I need to multiply to be able to do the jumps from 7 to 9. So what do I do here? Let's go back to the program. Here we go. So I do S2, which is how many, let's just see what S2 is. Go here, and let's go to S2. S2 is 2. It's the number of columns in B. So I'm taking S2, which is the columns in B, in array B, and I'm multiplying it by my counter, which is still 0. But it could be 1 next time. So if it's 1 next time, it'll be 2 times 2, I'll go to place 2. And then it'll go to 3, and then it'll go to 2, it'll be 2 times 2 is 4. So it's going to go 0, 2, 4. It's going to jump by the amounts that it needs to get to the next horizontal row. There is going to be an issue with, like, well, what about the next time when I need to go to not to 0 to 0, 2, 3, 0, 2, 4. What about if I need to go to 1, 3, 5? The truth is, I'm probably going to have to add another counter here. It's going to get more complicated. But for now, let's just look at it like this. Probably going to have to add a 1, add a 0 to this result. This result I'm putting in T4. Probably I'm going to have another line here. And then I have to shift it twice. I have to make it 4 times. So then I got the right index. Now I have the right index because it's 4. This multiple, which is going to be 0 the first time, and it's going to be 2 the next time, but then it's going to be times 4. It'll be 4 because I have to go 2 times 4 is 8. It'll be 8, so that'll give me the correct location. But probably I'm going to have to add to it, right over here, some kind of add where I add a pointer which tells me, yeah, but am I on the first column or the second column or the third column? What column am I in? So I have to have an add, like another counter here, like another 1, 2, 3, and then I'll multiply by 4. So I was missing that step, but you'll do that yourselves. Then I've got the number here, 4 times. So I've got the number, and I've got to create a new pointer, actually. So I got to take the pointer to B, which is T1, add to it this index, and get the new correct index relative to the beginning of the array. And now I store the number in K1. And now that I've got K1 and K0, I can multiply them, store the result, which is going to be, let's say, 7 the first time. Right? Let's see in my example. My example, it's going to be 7, right? 1 times 7 is going to be 7. So, back to the program. I'm going to store the result in, which is going to be like 7. I'm going to store it in T7. Now, what's T7? Let's go up here for a second. And T7 is the sum for the product of the matrix, for this product matrix. Now, there's the third matrix I'm calling the product matrix because it's you know, I'm going, that's where I have the product of the A and B. So I have to have a sum for that because it's not just, I'm not just going to put 7 there. I'm going to put 7 plus something and a plus something. So that's the T7. So I add it to T7. Now, in the meantime, T7 is 0. So it'll be 0 plus 7. So it'll be 7 still. But the next time, it'll be 7 plus whatever I compute again. And that way I'll take a sum. And then I have to increment my T2, which is my counter, my regular counter, which I never changed up to now. It was 0. Now it's going to be 1. And I go again. I'm going to do my loop. So that should go through the first 3 elements, the first 3 columns in row 1 in matrix A, and the first 3 rows in column 0 of matrix B, and I should get the result in T7. Now, what do I do with T7? Well, first thing I do is I have a counter, which is T6, which tells me where to put it in the third array. T6 is started off at 0. So it's 0 in the meantime, but I have to multiply it by 2 because it's going to go 0, 1, 2, 3, and I want to go really 0, 4, 8, 12. So I'm going to multiply it by 4 by shifting it left, but I'm not going to affect it. I'm going to store it in T3. In T3 will be the result. T3, then I have to add to the pointer T8, which is actually pointing to the beginning of array C. That's what I did. Look over here. T8 is here, C. See that? So now I have a pointer with its index, and now I can go to index location 0 of that new pointer and store my value. Then I have to add 1 to my counter for the final array. And I'm going to have to do again this loop. Now, the next time I loop is going to be something's going to change. So we're going to have another counter here. I leave that to you. And then you have to print out the arrays. So I basically did most of the work. The hard part is this calculation of the multiplying. The only hard part that would have trouble for you guys is to figure out how to jump through the array in the right increments. Now, not just by 4, but by multiplying by the column number or the row number. So that should work. Let's run it. And I run it, and what do I see? Why don't I see the values? Wait a second. Oh, guys, sorry, I didn't enter in the values. I got to enter the values. Run it, and I type 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and it finishes. Now look what we see. 1, 2, 3, 4, 5, 6, and that's the end of that one. And then 7, 8, 9, 10, 11, 12. And then the first value in the third array is 58. That 58 is exactly the 58 that should be there. Okay, so I hope this helps you. Good luck on the homework, and good luck in the course.